Hello, everyone. Welcome to session number 5 of GraphQL Real-Time Race Workshop. My name is Stefano Sandrini. I'm a specialist solutions architect working in the front-end web and mobile area here at AWS and helping customers worldwide to build web and mobile application leveraging modern API. Today, we will build a live real-time race component for our workshop. So let's jump into today's agenda. And let's talk about today's topic. So live real-time race data. We are going to show to our end users live data coming from multiple data sources. These data sources can be a car on the track, can be a sensor that is embedded on the track or embedded on the vehicle. So a sensor that provide data about the temperature of the engine, for example, or the gear, or the current speed of the vehicle. Data can also coming from the official timing system for the racetrack and for the race to provide the last lap time, for example, so we can have a better understanding of who's the fastest driver on the track. So we are going to collect all these data together, and we are going to provide to our end users a live feed about updates. So again, updates about the telemetry or about the lap time. The first thing we're going to do is to have a walkthrough through the architecture, the whole set of components that we are going to use, set of tools and services that we are going to use to build the solution itself. And the second part of the session is about coding. It's about a hands-on part, and we will have a discussion at the end of the session itself. Before entering into the proper discussion about the architecture, a few prerequisites to attend this workshop. These are all prerequisites that you need to complete the whole workshop. So from session number 1 to this one, session number 5. So as a quick recap, you will need an AWS account with full administrator access to complete the hands-on part. You should use one of the supported regions. So based on the services that I will show you that we are going to use, you should pick the right regions that support the set of services. A familiarity with the AWS Management Console is definitely a plus. It's not mandatory, but definitely it's a plus. So you can have a better understanding of what we are provisioning, what type of resources, and what we are looking during the hands-on part, what we are showing during the hands-on part. For optimal compatibility, we suggest to use Chrome or Firefox as browser on a desktop or a laptop, so no tablet, again, to complete the hands-on part. And definitely this session, so session number 5, basically continues from everything we built in previous sessions. So again, if you want to follow the whole hands-on part of this session, my suggestion is to start from session number 1 and build everything, and then jump into this session number 5. One last part is about cost. Running the workshop might incur in small charges. All these services are, they provide a free tier, but if you run the workshop for a long time, or if you're ingesting a lot of data, you might incur in small charges. So as I mentioned, this is session number 5, and we are going to build the solution on top of what we built in the previous sessions. So just as a quick recap, in session number 1, we created the app, we launched the app, and we used, leverage the admin UI to do data modeling and to basically provisioning a GraphQL API based on Appsync, and leverage then the data store feature for offline and real-time data fetch at client side. In session number 2, we expanded the API we created. So basically, we created more enhanced and a more advanced API use case, leveraging GraphQL and Appsync. And then in session number 3, we introduced a new use case about real-time. So real-time interaction based on location. And we're going to use the same map resource we created in session number 3. So again, that's why you need to complete previous session before jumping into this one. And then in session number 5, we created a real-time chat. So people could chat about specific event in our race application. Now it's time again to build the feature about providing real-time updates for the real race event or session during a weekend of race. So let's jump into tools and services we're going to use to build this use case. So let's use a bottom-up approach, and let's start with backend services. We're going to leverage AWS Appsync. Again, we already deployed an AWS Appsync API in session number 1. We're going to use the same API. We're also going to use Amazon Kinesis data stream. So we're going to deploy a Kinesis data stream to manage the ingestion of data coming from the field, let's say, coming from cars, coming from the official timing system. We're going to leverage AWS Lambda. We're going to create multiple AWS Lambda to implement part of our business logic. And we're going to leverage Amazon Location Service. So as I mentioned earlier, we're going to use the same map resource we created in session number 3 to display in real time the position of a car on the track. Data coming from cars' official timing systems will be stored on an Amazon DynamoDB table. So we're also going to leverage Amazon DynamoDB as a NoSQL database. Everything is going to be orchestrated by the AWS Amplify command line interface. And also we will be using the Amplify libraries, so different categories from the libraries to interact from our front ends with all these backend services. Also, not mandatory, but if you follow the instruction set that we provide with this workshop, you're going to use AWS Cloud9 as an IDE in the cloud. Again, it's not mandatory, but definitely leveraging an IDE in the cloud, it's a good way to experiment with this workshop, with services we will use without basically changing your local laptop configuration. So let's jump into what we will build in this session. This is the target architecture that we are going to build. And again, it's about providing our end users with real-time live updates about race, about cars that are on track during a race. So we are gonna have our mobile or web application that we already built from session number 1 to session number 4. And through this application, we will send real-time notification. To send real-time notification, we will leverage GraphQL subscriptions. So again, leveraging the GraphQL API provided by the AWS Appsync, we're going to leverage a specific type of operation, subscriptions, that enable us to provide real-time notification to end users. This data is coming on the other side from multiple data sources, cars, sensors, official timing systems, and all these data sources are ingesting data into our system at a different rate and basically with different payload. So we need to find a mechanism, design solution to address these different payloads and different rate of ingestion. Also, we need to find a mechanism, a design solution to decouple the ingestion part from the real-time notification part. We don't want to send notification to our end users every millisecond, but maybe a sensor on the car will send us updates every millisecond or every 100 milliseconds. this is not doable, and we don't want to provide data with such a high frequency to our end users. So in order to address this scenario, we're going to leverage Amazon Kinesis data stream and Lambda. Amazon Kinesis data stream is a perfect fit for this use case because it enables us to create a stream for the ingestion data. And the ingested data, we can split the data that is ingested into multiple shards. So by leveraging these features, we can manage a very high volume of data, but providing real-time updates to our end users with the right frequency, based on the use case, based on the scenario that we want to address. Maybe it's a second screen application, maybe it's a live TV broadcast, maybe it's the application is used by an end users that is actually on the track. We're going to leverage an AWS Lambda function that can consume the stream. And again, this is a design patterns that we want to leverage so we can make some processing on the data coming from the cars or from the timing system. And with this processing, we can, for example, aggregate data. So again, we can provide a different rate of updates to our end users because we are aggregating data, or we can enhance data. So for example, we can enhance data coming from the cars with some editorial contents coming from a content management system, for example. All this data that is sent back to our end users through the subscriptions is also stored in DynamoDB table through a mutation invoked by the Lambda function against Appsync, and then Appsync will provide the right operation, so a put item in this specific use case against the DynamoDB table to store data, so we can query historical data later on. To build this architecture during the workshop, what we're going to do, we're going to build the architecture in 3 phases. So the first part and the first phase is about defining a new model in Appsync, a new type in Appsync, and defining a new subscription that is used by the client to receive real-time race event based on the event ID. So here the event ID is basically the event ID of the event type we created in session number 1. So for example, for a specific race, an event can be the free practice session, the qualifying session, or the race itself. So we can get real-time data just for the right session. Also, since we are creating a new type and we are going to use the model directive, we will do the provisioning of the Amazon DynamoDB table to store the data through the mutation. Data that we are sending to our clients, to our API consumers that are subscribed to notifications, is something like the one you see in the slide. It can be something about the telemetry, for example. So here we have a telemetry for driver number 1, and the payload provides the speed, provide the current gear, and provide the position on the track, so longitude and latitude, so the geolocation of the car. Data can also be something related to the lap. So for example, here we have something coming from the last lap time. So driver number 1 just completed the lap number 7, and the time is 1 minute 24 seconds and 237 milliseconds. So we can, for example, create something like this in our web clients. So a table with all laps completed and the lap time. And we can also provide in real time the official telemetry. So again, providing info about the gear or the speed. But since with the telemetry, we are also managing geolocation, positioning of the car on the track, we can also display on a map the current position of the car. So here we have an example in our racetrack, and the car is in the finish line. So this is what we can do with this type of payloads that we are managing. The second part of the workshop is about building a Lambda function that performs the mutation to Appsync to ingest data. So we will create a Lambda function, we'll create a mutation, and this mutation will perform the put item operation in the DynamoDB table, and then after that, automatically Appsync will notify users about new data has been created. So again, real-time updates. So this is what we're going to build in the second part of the hands-on. Also, we're going to provision an Amazon Kinesis data stream. So we will have a walkthrough on how we can do the provisioning of an Amazon Kinesis data stream. And again, how we can configure the Amazon Kinesis data stream to manage the ingestion from multiple data sources, and how we can configure the trigger from the Lambda function, so the Lambda function can consume the stream and then do some processing and then the mutation. The last part of the workshop is actually about creating a simulation. We don't have a real vehicle here with us for this workshop. We don't have an official timing system. We are not at a racetrack. So how we can test our solution, we can create a simulation stack. So we are gonna provision an AWS step function workflow that using another Lambda function can simulate telemetry data for a single lab, and then the workflow can simulate more than one lab, up to 10 labs. Also, we will use the DynamoDB stream from the event table. So anytime we create an event, and again, an event can be the free practice session on a Friday during a race weekend, or the qualifying session on Saturday, or the race on Sunday. Anytime we create a new event, we will have a new Lambda function that consumes the streams. And if the operation is the creation of a new event in the DynamoDB table, then the Lambda function will create a new execution of the step function workflow. So we can simulate data for the event itself. So that was the architecture part and the discussion around what are the services and tools that we are going to use. Now what we can do, we can jump into the hands-on part. So you can follow the instruction at the link that you can see in the slide. The link is always the same. So same link for session number 1 and 2 and 3 and 4. So same session, same link for the session. Let's jump into the hands-on part. Okay, so here I have Cloud9 up and running with the application we built from, again, previous sessions. And also I have on the left side the instructions provided by the link that I show you. As you can see, I am now in lab number 5. So you can navigate through labs, go to lab number 5, and we can start. So this is an introduction. So the first thing we have to do, again, is to create a new type in our GraphQL schema and create a new subscription. So what we can do, we can go to the Amplify folder, backend, and then inside API, we have the schema.graphql file. We can open the file, and we can copy-paste basically what we have in the instructions. So we can copy-paste the new type. And also, we can copy this new subscription and append it here. So now that we change the schema.graphql, we can ask for provisioning an update, basically for an update of our API. So again, we can copy the amplify push command and asking for provisioning resources. In the meantime, what we can do is let's basically have a look at what is this new type that we created. So we created a new type that is called race event. We are using the directive add model. So again, this is a way to map this GraphQL type to a DynamoDB table. It's going to be a race event DynamoDB table. This type is also associated with the event type through the add connection directive, leveraging the field event ID. So we are doing a referencing between the race event and the event itself. And then here we have a list of fields that basically, again, provide infos, for example, around telemetry, for example, about the lap time, the position, or the geolocation for the car on the track. An interesting aspect is about authorization. So here, as you can see, we are providing 2 additional authorization directive and authorization rules. So basically, we are saying all signed in Cognito users can read real-time race events, and all IAM credential users can read and create race events. So basically, all signed in users through the web application can fetch previous race events from the history log, or can subscribe to receive real-time notification about race events coming in real time from the track. But backend resources, basically Lambda functions, for example, in our scenario, can of course read data, but they can also create data. So this is how basically we can provide an authorization rules that specify that the Lambda function that we are going to create later on is able to invoke the mutation. So now provisioning is completed. And basically, we created a new type, a new DynamoDB table, and a new subscription. And as I mentioned earlier, subscriptions are a great way to notify a user in real time about new data that is available. But when the volume of ingested data is large, and also the type of data may be different depending on the data source, it's important to decouple the real ingestion from the field and the notification part. So in order to do that, we are going to leverage Amazon Kinesis data stream and AWS Lambda. So the first thing to do is to create a new Kinesis data stream. And again, Kinesis data stream is a perfect fit for our use case, because imagine you have multiple drivers, multiple cars on the track, and all these cars are sending data to our system. We really need to aggregate data, or we need to change the frequency of update to our end users. So definitely we need to leverage a Kinesis data stream. So in order to do that, we can ask for a new Kinesis data stream using the add analytics. We can select Amazon Kinesis stream. We can enter a name for the stream. We can just use the default one. And now we can enter the number of shards. And again, for the sake of this demo workshop, we can just leave the number of shards to 1. But a very important thing to remember is, as soon as you go to production with a solution that is very similar to this one, you need to carefully identify what is the right number of shards that you want to use based on the throughput that you want to achieve. So based on the throughput or the ingested data, you may want to leverage more than 1 shard and configure Kinesis data stream accordingly. Then what we can do is basically we can create the Lambda function that is going to be triggered anytime a new real-time event is ingested into Kinesis data stream. So we can use the amplify add function command. We are going to request a Lambda function. We can use this name, process live events, for the function name. We're going to use Node.js as runtime, and we are not going to use the hello world template, but actually a Lambda trigger template. Because again, here we are triggering the Lambda function because of a new record is in Kinesis. So we need to create a trigger. We can create a trigger and specify that the source that it is associated to this trigger is the Amazon Kinesis stream. So we select Amazon Kinesis stream, and then Amplify basically is going to ask, do you want to use the Kinesis stream that you are going to provision through the analytics category, or do you have an already existing Kinesis data stream? So again, maybe in a real use case scenario, maybe you already have a Kinesis stream, you can provide the REN. For the sake of this workshop, we just use the analytics category. Then we need to configure advanced settings. So we configure advanced settings, and more specifically, we want to specify other resources that our Lambda function need to access. So we need to select yes here. And the resources we need to access from this Lambda function are API and analytics. So you can move between the selection, and just remember you need to hit the space bar to select a specific category. So we selected API and we selected analytics. For the API, we need to select the operation that we want to permit, and we need to permit mutation, because again, this Lambda function is going to perform a mutation to Appsync to save data into DynamoDB and then notifying our users. So we select mutation again with the space bar. For the analytics part, we need to select the Kinesis stream. So again, hit the space bar in the real-time Kinesis stream. And then we need to specify, again, the type of operation. Here we are asking permission for reading the Kinesis stream. So we can select the read option. And now, as you can see, basically what Amplify CLI does is displaying what are the environment variables that will be available within the Lambda function, basically to as a reference to the resources that we just use as a trigger for the Lambda function itself. So the GraphQL API to perform the mutation and the Kinesis stream. We do not want to invoke the function on a recurring schedule, so just select the default no. And we do not need any Lambda layers, so just select no. So we created a Lambda function, at least from a configuration perspective. Now what we can do, we can edit the code for the Lambda function. So just let me close this one. Now what we have under the function table, under the function folder, we have the process live event folder, and we have the index.js file. So this is a dummy file, basically based on the template. So we can, again, copy to clipboard the code provided in the instruction and paste the code here. We will have a walkthrough of the code in minutes. So we can save the index.js file. And what we can do now, we can perform again an amplify push to ask a provisioning of both the Kinesis stream and the Lambda function. And in the meantime, what we can do, again, is to have a look at basically what the Lambda function code does. So in the event object received by the Lambda functions, we iterate over the records. because basically, based on the configuration in our trigger, we are triggering Lambda function because a new record is ingested in the Kinesis data stream, but we may have multiple records in the event. So we iterate over records, and we create a payload based on what we are receiving. We are identifying some mandatory fields, basically, for our input. So basically, the event ID, the type, so telemetry, for example, is a type, the competitor, and the lap. Then we set some optional value. For example, again, the lap time, the position in the ranking, the geolocation of the car, the speed and the gear. Again, based on the type and based on what has been sent by the car itself, or maybe the official timing, we may have a field or not, so we can set the value in our input. And then we perform this request. And basically, this request is an HTTP request against Appsync. And we are performing this mutation, create race event mutation. We are specifying the create race event mutation here. So it's a classic GraphQL mutation that takes the input we provide as a parameter. An interesting aspect here is the selection set. So as you can see, basically, we are requesting all available fields in the selection set. So all fields from the race event type are requested. Same for the event. This is important because in this way, all subscribers, so web application, mobile applications that subscribes to real-time notification, can then specify their own selection set in the subscription. So maybe you just want to be notified about the type and the longitude and latitude because you're just displaying the geolocation position. You can do that because the mutation is returning these fields. So this is super important. And here basically is the definition of the request. We are performing an HTTP request against the Appsync URL, and this is the operation. Okay, so provisioning is completed. Now what we have to do is we need to simulate our cars on the track. We created a type, we created a subscription, we created the DynamoDB table, and now we also have the Lambda function and the Kinesis data stream. So all the backend part is set up. We just need to find a way to ingest data on the Kinesis data stream. And again, of course, this is a simulation. So on a real scenario, what you would have is probably you would have maybe an API gateway here, or maybe you will have a Kinesis producer that can send data in the Kinesis data stream, for example. This is an option. Maybe you have AWS IoT in place in your real scenario to collect data coming from sensors, for example. You can map AWS IoT to the Kinesis data stream through an AWS IoT rule, for example. So what you have before Kinesis data stream is really depending on the real scenario. But in our specific case, what we're doing, again, is to create a step function workflow based on a Lambda function. And then we create an execution of this step function workflow anytime a new event is created on a DynamoDB table mapped to the event type. So the first thing to do is actually to create the Lambda function that simulates telemetry data for every lap. So this Lambda function here that is part of the step function workflow. So let me clear our terminal. And again, we can use the same command we used before, amplify add function. We are creating a new Lambda function, so amplify add function. We create a Lambda function, not a Lambda layer, so select Lambda function. Let's use simulate race event as a function name, because we're simulating real-time events for the race. Still using Node.js for the runtime. As a template, we're going to use hello world because this is not related to any trigger. So just use the hello world as a template. We want to configure advanced settings, so yes. And we want to configure access to other resources, so yes again. So here what we have to do is we have to provide permission to our Lambda function to interact with the Kinesis data stream. So if here on the left side, I go back to the architecture, as you can see, the Lambda function actually interacts with the DynamoDB streams to ingest data in the stream itself. So we need to provide basically permission to this Lambda function to interact with the Kinesis data stream. So we can select analytics, again with the space bar, and then enter. We select the Kinesis data stream, space bar, and then enter. And then here, what we do is basically we provide permissions on create, read, and update for this Lambda function. So based on this configuration, these are the environment variables provided by the amplify CLI for the Lambda function. So basically the Kinesis data stream resource name, the environment, and the region. We don't want to schedule this Lambda function on a recurring base because we are leveraging step function workflow. So we can just say no. We don't need any Lambda layer. So again, no. And we don't need to edit the function now, because actually what we have to do, we have to do some additional configuration. So at first, let's create the code for the function. So we have the simulate race events here. So under the source folder, we have the index.js file. We can again do the copy paste. And we can save. And again, we will have a look at the code later on during the provisioning. But the important thing to understand here is that basically, as you can see, we have these two additional require. So we are leveraging two additional files, telemetry and events. Basically, these are two files that we can use to simulate data for the telemetry or for the lap time, basically. So what we can do, we are providing you this zip file that you can basically copy, and you can paste. So you can download. You can go to the amplify backend function simulate race event folder in the source folder. So here you can do this. And then you can unzip. Now we can remove additional folders coming from the zip file, and we can remove the zip file itself. So what we have here is the telemetry file, for example, that provide, as you can see, sample data, sample simulation for a car on a track with speed, with the gear, and with the geoposition. And we also have events around lap timing for each lap that we want to simulate. Then what we can do, basically, we can provide some additional configuration for the Lambda function. The first thing is to actually change the timeout of the function. We can do that by editing the CloudFormation template that is automatically created for us by the command line interface. So it's a standard CloudFormation created by the CLI. As you can see, the timeout now is 25 seconds. We can change it to 90. Because basically what we're doing here is, again, this Lambda function is going to simulate a single lap with all telemetry data. If we basically go back in the events, as you can see, lap time is about 85 seconds, 84 seconds. So that's why we are setting the timeout to 90 seconds. And then what we can do, we can from a push. So we can ask for provisioning this Lambda function. Just copy command here. In the meantime, let's have a look at what this function code does. So the function code receives an event. The event basically contains the lap number that we want to simulate. Then, based on the lap, it just retrieves data for the lap itself. So basically, the total lap time that we want to simulate. So reading data from the events, lap data is here. And then it just iterates over the events provided by the telemetry file. So iterating over the sample data that simulates an entire complete lap across the whole track. So we are creating a type of telemetry. We set some data. And then what we do is we perform a put record on Kinesis. So here we are ingesting data into the Kinesis data stream, and this data is related to the telemetry. We are simulating sampling data every 700 milliseconds, between 700 and 800 milliseconds. And then after the iteration over the whole sampling, we are also ingesting a new record in Kinesis that it's about lap time. So basically, we provide the lap time for the lap that has just been completed. So again, this is just a simulation, but at the end of the day, it's what a Kinesis producer does. So if you have something already in place and you want to ingest data into Kinesis, data coming from different sources, basically this is how you can put record on Kinesis, and then you can leverage Kinesis. Another interesting thing is the partition key. So here we have the partition key. And for the partition key, basically we are using the combination of the event ID and the type. So in our specific workshop, currently in our configuration, we just have one shard. But let's say you have multiple shards, basically providing partition keys that are related to event and type enables you to spread across multiple shards, to split across multiple shards the data that is ingested. So for example, you may pick as a partition key just the event ID. If you have multiple events running at the same time, Maybe you are building an application for a broadcaster, so you want to provide in real time notification about multiple events, multiple different sports, different race, things like that. You can use the event ID, or you can use, again, the type, just to have a split based on the type itself. So you may have types around telemetry that has a higher ingestion rate, for example. You can play a bit with this combination to, again, to adjust the throughput based on your needs. So we created the Lambda function, and the function has been provisioned. So again, that's clear. The console. Now what we can do is we can create custom resource for step functions. So why a custom resource? Basically because step function is not natively supported by the Amplify CLI. So we can extend, we must extend the set of resources that are currently managed by the CLI with a custom resource. So we can extend, so we can use custom resources by basically declaring additional categories in our backend config.json. So in the Amplify backend folder, you have this backend config.json. And if you take a look, basically here we are describing all the categories managed currently in this project and all resources per category. So what we can do, we can actually, at the bottom, add a custom category. And this custom category is this one. So is basically step function. Let me just better syntax. So here we are defining a new category called step function. And inside this new category, a new resource called process workflow. Also, what we're doing here is we are specifying that this process workflow depends on the simulation race events. So, for example, we can ingest references to the simulation race events Lambda function into the process workflow definition. So we can basically specifying what is the Lambda function that we want to leverage, basically by following this syntax. So, and this is how we specify a new category and a new custom resource. But now what we have to do, we actually have to replicate the same folder structure that Amplify expects for a category. So for example, in the API, we have the name of category, API, and then the name of resource. And then in this folder, all assets for that resource. So we need to replicate the same structure. So in Amplify backend, we must recreate the same folder structure. So the one that is specified in the instruction. So we can create a folder step function, and then inside step function, we can create the folder process workflow. Because again, this is how we are naming our new resource. Now, because Amplify CLI expects a specific folder structure and it use a specific naming convention, we also need to create two additional files. The one is related to the CloudFormation template. So basically, we can create this file. Process workflow CloudFormation template. So the name of the resource and then CloudFormation template is going to be a YAML file, and then also parameters.json. So we are creating all these things manually, and this is a way also to understand what is the type of job that the Amplify's CLI does for us. Usually when we create a category that is natively supported, it creates all these things for us automatically. So we can now edit the CloudFormation template that is empty currently. Oops. Copy here. See the file. And then I think I need to rerun the creation for the parameters file here. So now we created the definition for our resource through the CloudFormation template. We need to make the Amplify CLI aware of this new resource. So we have this command, environment checkout. So usually you use this command to switch between multiple environments. Basically, if we do the checkout to the same environment we are already using, it will just refresh the configuration, and the CLI will be then aware that a new custom resource is available. So we do the Amplify environment checkout. And if I run now the Amplify status, you'll see that a new category, step function with the resource name process workflow, is in operation create. So basically we can ask for provisioning this category and this resource for us. So let's clear a bit the terminal. And now we can push our changes. So again, Amplify push. Copy the command, Amplify push. So again, in the meantime, that provisioning is executing. What we can do is we can have a look at the CloudFormation template. So as you can see here, we have as input parameters the reference to the Lambda function. If you remember, we put the depends on section when we define our resource in the backend config JSON. And basically, it just follows a specific naming convention. So name of the category, name of the resource, and then the output. So name and REN. And then we have basically the definition of the step function workflow. So it's a JSON that we use to define our state machine. And this definition string basically leverage two input parameters. One is the function itself, because we need to reference the execution of the function within a specific state, and also the wait interval in a second. And this is, again, is a parameter. We have a default value of 1. So basically, when the execution of the Lambda function is completed, so one lap is completed, the state machine will wait for 1 second, and then we'll start the simulation of the next lap, basically. So the provisioning is completed. So what we can do, we can actually go to the step function page. And you can see that we have our process workflow provisioned, and we have the definition. So if we close this one, we have a better view. So this is the step function and the state machine that has been deployed based on the definition string that we provided. So again, the state machine just wait for the due date. So this due date is basically the starting date time for the event. So let's say you want to simulate the free practice session on a race weekend. It has a starting date and a starting time. This is the wait for due date. And then it enters into this get race lap data that basically simulate a single lap with the telemetry data. And then we have some checks. So basically, do we have more lap to simulate or not? If so, we wait for 1 second. If you remember, we have 1 second as parameter for waiting. And then we will restart the simulation again. So basically, this is how we simulate a car on a track. So let's go back to our Cloud9 instance because we are not done yet. So we have our step function workflow. Let's move back to the architecture in the left side. We have the step function workflow. We have this Lambda function. This Lambda function is now able to invoke a put record operation to this Kinesis data stream. We just need a way to automate the execution. So the instance of a process, of a simulation process, basically. So what we're going to do now, we're going to create this Lambda function that consumes the DynamoDB stream from the event table and then invokes a new execution for the step function workflow. So let's go back to the instruction set. And let's add the Lambda trigger for the race simulation. So again, we are adding a new function. We are going to select Lambda function, not Lambda layer. Let's call the function race simulator race simulation scheduler, because it's just scheduling new simulations. Node.js is runtime. And then again, we need to select Lambda trigger because we need to consume the DynamoDB stream. So we need to create a trigger for the Lambda function. Lambda trigger. In previous section, we selected Amazon Kinesis stream. Now we can select Amazon DynamoDB stream. So we can select the DynamoDB stream. And now we can basically, again, pick a DynamoDB table that we created through the storage category, providing an external DynamoDB stream, or we can say, let's use a model from the API category. And this is exactly what we need because we need to consume the DynamoDB stream related to the event model. So we can select this one, and we can select the event. Again, spacebar to select. This is a multiple selection. So spacebar on the event, and then hit enter. We don't need to configure additional settings, and we don't need to do this now. Because before editing the function code, we need to provide, again, additional configuration. So since we are interacting not just with the DynamoDB stream, but also with the step function workflow, we need to provide additional configuration to interact with the customer source, because it's a customer source. It's not managed automatically, let's say. So we can go in the function folder in the race simulation scheduler. And basically in the CloudFormation template, which is basically this file here, we can add an additional parameter in the parameter sections. So we can add this parameter here. Just make it a little bit easy to read. And here we have our additional parameter, which is basically the step function workflow. We need a reference to the step function workflow because we need to provide access to this step function workflow for the Lambda function to create a new instance and a new execution. Since we need to reference the state machine, we basically need to add also an environment variable. So we can add this state machine environment variable. So we can go to the Lambda function definition. And here we have environment variables. So we can add this additional environment variable. So again, let me make it easy to read. So now we have the state machine resource name as an environment variable, so we can reference that name, that resource name in our Lambda function to create the execution. And then we need to add one last resource. So at the bottom of the resource section, we need to add a custom resource policy, because again, this Lambda function needs to create an execution. So we need to allow the start execution for the step function workload from this Lambda function. So basically, again, we can copy and this is our last resource. We can save it. Then what we need to do, we need to create a parameters.json file in the same folder for the CloudFormation template. So let's create a new file, name it parameters.json. Open it. And basically, we need to provide input parameters, again, because of the customer source. So since in the CloudFormation template, we are asking for this specific input parameter, we need to specify it in the parameters.json. Now we can edit the Lambda function code. So we can open the index.js file in the source folder for the race simulation scheduler Lambda function. And again, we can copy the code here, and we will have an overview during the provisioning. So we can copy the code here, and now we can ask for a push. Amplify push. So this is basically a Lambda function that consumes a DynamoDB string, and based on the event that it receives from the stream, creates a new execution for the step function workflow. So to do that, it looks similar to the one that to the Lambda function that consumes the Kinesis string. So again, in the event object, we have a records list. We iterate over the records list. We marshal the payload so we can have a better an easier payload to manage. So if the event name is insert, so basically if we are creating a new event, what we can do is we can create a new execution. So we are referencing the step function module within the SDK, and we can invoke the start execution function. We provide the state machine, resource name, we provide the input, and basically the input provides all the fields that the state machine is expecting. So for example, the planet race start. So the date time for that is checked by the wait for due date. So the planned race start is basically what is checked here. Wait for due date is checking planned race start. So that's why we are, anytime we create a new execution, we need to provide this value. And the value is basically the date for the event. So again, you have a race weekend, Friday free practice, Saturday qualifying, and Sunday you have the race. What you can do, you are simulating the qualifying session, okay? Planned race start is basically Saturday at 3 p.m., 2 p.m., things like that. And then, of course, we provide the event ID, because if you remember, all telemetry data, all real-time data, everything is mapped with an event ID. So provisioning is complete. And now we have the whole infrastructure and the whole architecture. So just as a quick recap, now we are in this specific situation. What we can do now is basically we can, let's open the menu, add the real-time race events to our application. So we can move to the front end and leverage what we created to display in real-time events. So if you follow the instructions in previous labs, you already have under the pages folder this live race file. You can change the content with what is provided here. Please remember, anytime you see a blinking star, you need to expand, and then you can find the code. So you can copy the code, and basically we can paste it here. Again, we will have a walkthrough on the code later on. Now what we can do, we can basically start our application. So we can do yarn start. We can start our front end. You can also publish, since we have the hosting ready. We can do both. We can just start a development server locally in Cloud9 and then launch the preview mode. This is what we are going to do now. What we're going to do now is basically entering the application, and then we are going to create a new race event, because we need to trigger the execution, the step function execution. So let's enter in the preview. Let's make it bigger, I would say. We can close this one. We have events here. We have also this live race page. So as you can see now, what we have is the map for our track and some panels for the timing and the telemetry, and we can select races. Basically, we can select events. So what we do is basically we perform a list events query, GraphQL query, to retrieve all events to populate this selection. And then anytime we select a specific event, we basically subscribe for real-time updates for that specific event. So we can just display data for that event, for the event that it is selected, basically. And then we can, anytime we receive an event, we can display the right data based on the event type. So all these events actually were created before our trigger, so we don't have any execution for step function, right? So we can create a new one. We can use the admin UI. We can hit create event. And let's say we are racing on Monza, right? So we can do Monza free practice. Select daytime. Just keep in mind this is UTC, so we can do something like this. Free practice test, something like that, and just put some heart, thumbs, and happy. We can save the event. So if we go here, we have the Monza event. If we go to the step function, we go to the execution. Now we have an execution that it's in the wait for due date. So let's move here, live race, select Monza free practice. And what you can see, we are the simulation started because I put a date time that was basically immediately after the creation. So you can see here that we have the official telemetry with the gear, with the speed, and with the geolocation position in real time, based on the simulation, based on the sampling, right? And these data is basically displayed because anytime we receive an event, so I'm on the left side, what we do is if the race event is telemetry, if the race event type is telemetry, we set the gear and the speed, and we have a gear and speed value. It can be null. So if it's not null, we set the last event with gear and speed. So basically, we can display the last received gear and speed value. So basically, the current value. Now we are completing lap number 1. So we're not receiving a telemetry event. We are receiving a lap event. So what we have here in the official timing section, we have lap 1 with a timing. Now we have lap number 2 live now. So we are the first corner, the first chicane, and now again in the second straight. So gear 7 and this speed. So again, based on the type, we set like a last event, which is a state value to display the current gear and speed. If we are receiving a lap event, basically what we do is we put that event in this list so we can create a table. And also, as you can see here in the left side with the code, we have this set marker. So the set marker is a function to set in the state of this React application the marker. So basically the position. So this red icon here. So anytime we receive a new latitude and longitude, we set the marker. And basically by setting the marker in real time, we just change the position of the icon on the track. And this is how we basically create this real-time position on the map. Lap number 2 has been completed. So we have lap number 1, lap number 2. If we go back to the step function, as you can see, wait for due date was green. So we started. Now we are in get race lap data. Race completed was checked. And basically, race was not completed. The session was not over. So we are simulating another lap. Just to show you basically how we display the marker, again, here we have the set marker. We are basically leveraging the same map that we used in session number 3 to display real-time location event. The difference is basically that we have this marker here that is mapped to the marker state value, state variable. So anytime we change this variable here, basically we change the value for this marker. And again, this is how basically we display the position on a map. Another lap has been completed. So we have now lap number 3. So this is basically how you can display in real time live events for arrays. This is for a free practice, so we just have one driver, but basically it's the same thing. And again, depending on the volume of ingested data, you have to play with number of shards and maybe aggregating data in the Lambda function that consumes the kinesis string. So that's basically the concept. This was the last part for the session number 5 and also for the workshop. Just please remember that you also have this cleanup section, here. Just follow the instruction here, basically to when you're finished, when you're done with the workshop, if we want basically to avoid charge because you're running resources basically. So you can clean up all resources provided by Amplify with this command. So that was everything on my side for this session. We created a GraphQL real-time solution for showing in real-time events for a race or for a session within a race weekend. Here you have also my Twitter account. If you want to reach out and ask additional questions, you can do that. And thanks for watching.